Okay. I cannot hear myself. Let's see now. That is not good. Yeah, perfect. Now I can hear myself. Alrighty. Welcome everyone. Let's see. I can take this away. Let's see now. I'm gonna post the link on LinkedIn because why not? Let's try this one out. You never know. More people may be having a lazy morning. Lazy Sunday morning with hey, hello everyone. Wait, I'm gonna discard this draft. Let's see. Let's just say hello. Usually people say hello network. I just want to say, did I copy the link to the stream? Good lazy morning. Good lazy Sunday morning. Wanna come over to my YouTube stream for coffee? PS. I really like this picture. I don't know why YouTube takes this as the default thumbnail for the stream. I saw that yesterday as well. But I'm really happy they do because I took this picture in Gothenburg actually. It was a very beautiful evening. It is a little bit edited, of course, but that was not exactly how it looked like. But I was really proud of that picture. It's taken from a phone as well. Let's see. Coffee is not provided, but hopefully some Python learning. So today we're gonna look at the day. What was it? Let's see. At the Advent of Code, day 19. At the Advent of Code, day 19. Coffee emoji. I love emojis. Cute. Perfect. I'm just gonna post it there, and whatever happens. Goodbye. Let's see. Perfect. So, yesterday I did a little bit of that, and let's see now. What's here? Okay. Yeah. So I did a little bit of that yesterday, and I did run into an issue. So I'm maintaining my solutions here in my GitHub account, and I made this pull request here, which I'm having an issue with the tests actually. So some tests are not running here, or it's failing because we're not even actually using this right now actually, or like there's no need to test it because the library doesn't have anything really to run here. The one I was trying to make on the side at least. From the file name, so the problem here is that this is a directory. Okay, and what's the problem with that? It's trying to start the app, convert to notebook signal, and then what? It's trying to open. Oh wait. No. Okay, this is a problem with my task runner actually. Not task runner, but my Python tester. I have some solutions let's see here. Yeah, I have I have this folder. Okay, I see what's happening. So in here, um, this is the Python script that just tests all my Jupyter notebooks, and it's pretty dumb, really. I just list everything in this folder, solutions. But now in solutions we have outputs, so I have to add some exceptions here. How do I just need to escape these, but I don't want to do it so badly. So what was the error it threw actually? As is a directory error. Okay. Maybe I can just catch this one. Yeah, if it's a directory, just skip it. So just try to run these. So basically what it does is it runs all my notebooks one by one, and it tries to see if we got anything right or wrong. So basically, it did try to run. Yeah, it did try to run the outputs one. So we don't even want to show this at all. So what I'm gonna do is, actually, doesn't matter, but I'm gonna move this down here so that doesn't show up. Yeah, let's see. So this one run everything. Okay. Okay, no, it's fine. So no, it's okay. I can keep that up here. So what I'm gonna do is I'm gonna try to run this, but if it returns this is a directory error, then we just continue. And I don't need to, or maybe I can print skipping this one. What is NB maybe? What is yes, because it's not a notebook actually. So if we save this, perfect. Oh, and it also run black here. Black is a pretty cool formatter. Hey, welcome on the stream. So black is a pretty cool Python formatter, which makes let's see, Python black, and basically it makes your it makes your code super nice every time you run it. So what I've done is it's a code formatter. So every time I save, I think this is a setting in here, user settings, I think, and I can do black maybe, or yeah, there you go. So yeah, I've selected my formatter, but I also have a configuration somewhere. I always forget where these things are. Formatter maybe format on save. Oh, there you go. Yeah. So a formatter must be available. Yeah. So every time I save a file, it automatically runs my formatter, and I've set black as my default formatter for every project I am in. I realized, is the stream still going? It seems like I'm getting some odd. We're gonna get some feedback loop here now. It seems like it's still going. Okay, that's perfect. Okay, never mind. It just looked at like it wasn't. So yeah, back to it. Hey, nice of you to join. So back to it here. So now what we're doing is we're skipping the this notebook actually, because it's not a notebook. It's if it throws directory error, it's a directory actually. So if I save this and try to, let's see here. What did I change here? Okay, nothing really. So if we try to, all right, so we did this change. Let's just push this one before we start. So let's wait until maybe some more people join. So I'm gonna just fix this and say git commit the message. Emojis everywhere. Let's say this is a an eagle. Why not? Avoid directories. No, not the most elegant solution, but it should work. So if we push this, we should see. Yeah, but I'm using my iPhone as a camera because, well, obviously the MacBook Pro, the MacBook camera sucks, and I found this a repository a while back. Quite simple solution actually. This folks, this guy here or lady, they just wrote a simple HTML file basically, which has these 3 buttons. And it sets video autoplay by default and just captures the camera video from with some JavaScript from the phone. So you can either connect your front-facing camera or back-facing camera, and you do that. It basically loads your webcam in the browser. You put it to full screen, which is another button here, and it's handled in JavaScript. And then basically what you have to do is connect your phone with a USB-C cable to your MacBook. And then you can share your screen from your iPhone menu to your MacBook. And then that screen can be an input to OBS. So that's how I've set it up. Let's see if we got anyone. Oh, somebody. Good. Nice. Nazma, nice. We got some folks over on YouTube making expert. Oh, pretty cool title. We got some folks over on LinkedIn. Let's see if we get anything going here. Pretty fun. So yeah. So let's go back to it. So let's see now. It should not. So what I did is I basically fixed my runner to avoid if there's so if this tries to run, but is dictionary, it throws an error that it's a directory. We just skip it. So let's try. No, it failed. Okay, I have a clue as to why it failed. Yeah. So the reason is actually I'm running these asynchronously. So that's not obviously gonna work. So actually I know how to fix this. Yeah, there's a better way. So what we will do here, hey, welcome on the stream. We will just make sure to only run if, so I'm taking the notebooks here. So these should end in, what did I do here? If not, then we convert in, okay. And then they should also end in, if, dot ipy and b in is the chat disabled? Live chat. Hey. Perfect. Just making sure I can see the chat as well. So yeah, so we don't want if our NB in the name of the file we're looking at has the IPython notebook ending. Not very safe, but still, we want to run this. So now if I save this, and let's see, git status, add it, we can, sorry, git status, yes, perfect, git commit, actually only take IPy notebooks files. Perfect. Push this one, and now it should work. So now our GitHub action that tests if we broke something in the code should work. Let's see. Let's try this one again. It's queued. Have you ever had a frappe? I didn't use. I come from Greece, and in Greece I didn't used to drink that much frappe at all. But ever since I moved to Sweden, and I realized people love frappe, so I just started making it, and I brought the equipment from my home. Because they only sell these machines, these like hand whispers, how they pronounce, in the supermarket in Greece. I couldn't get a hold of them in Sweden, sadly. So I brought some back. I gave some to some friends as well, and now we've all been making frappe for for better or worse. Um, so yeah, so let's see. It seems like it is running sequentially though. So let's see. It should not run my solutions output file now. It should only run IPy notebook files. Yes. Um, let's see. Day 11. Yeah, I think actually it already worked. Perfect. Yeah. And so GitHub Actions is this amazing CI/CD tool, continuous integration, continuous development thing that is built into GitHub now since a couple of years. So we can set the actions to happen every time we do something to our code. So for now, I only have like to run tests on my code every time I push an update. Nothing. The tests are not particularly good, so it's just run everything and see if something breaks. So very basic, but better than nothing. So yeah. So now that we're pretty much done with day 11, we can just leave this there and move on to day 19 as promised. So I'm gonna actually branch out of here and not name it left day 19. Is it 19? Let's see. So it was published this morning. I was reading it in bed a little bit. It's let's make this. So it is quite a bit of a tricky one. So I have to say I will not spend more than maybe 1.5 hours trying to solve at least the first puzzle. Yesterday I spent 5 hours just because I didn't have anything better to do on a Saturday evening apparently, than like making my code look nice or to anyway. You can spend too much time on silly things, so don't do that if you don't need to. Hey, welcome to the stream. And so let's start with simply reading, I guess, what this challenge is today. So if you're not familiar with Advent of Code, it's a calendar of that starts on the 1st of December and goes all the way out to the 25th of December. And every morning at 6 in the morning, Swedish time at least, they release a new puzzle. So there've been quite a few puzzles. I kind of gave up quite at some point. I wasn't doing them anymore, but I thought, why not? Let's it's been an easy week lately, so, or like a little bit more free time. So let's do this. So let's take a 19, so you can see I've solved a few ones in the past. So this the case is we're in a submarine, and we currently have let's see, we have lost our keys in the ocean floor, and we're in the submarine trying to find the keys because it's the keys to the sleigh, and if there is no sleigh, then nobody's gonna be able to, if we can drive the sleigh this Christmas, nobody's gonna be able to get the present, so we gotta better find the keys. So let's see what it goes here. So as your probe drifted down through this area, so I've missed some parts of the story, so we're just gonna try to freebase it a little bit. So I'm guessing our submarine has gone quite deep in the ocean right now to find the keys, and so we are releasing an assortment of beacons and scanners into the water. So beacons are things that emit information in signals. Scanners are receivers. So I guess the scanners are able to listen for beacons. It's difficult to navigate in the pitch black open waters on the ocean trench, but if you can build a map of the trench using data from the scanners, you should be able to safely reach the bottom. So we're gonna use the scanners to figure out how the beacons to figure out how the ocean floor looks like, so we don't crash on something. The beacons and scanners float motionless in the water. They all float. Oh, okay. They're designed to maintain the same position for long periods of time. Why though? Each scanner is capable of detecting all beacons in a large cube centered in the scanner. Beacons that are at most 1,000 units away from the scanner in each of the three axes have their precise position determined relative to the scanner. Okay, so if our beacon, so let's read this one again. Each scanner is capable of detecting all beacons in a large cube centered on the scanner. Okay, so the scanner sits in the middle of this. Can I have like a sketch thingy? Yeah, I don't even know. Can I? How can I sketch things? Is it like a? Do you have a sketchbook? Oh no, I remember this app. That was not very good. Whatever. We can do Photoshop maybe, I guess, or as it's a bit annoying. Is there like an online sketch thingy that we could use? Sketchpad. Okay. Oh. It seems like it has some memory of me doing something in the past. Can I clean everything? Like, do you have to update to clean everything? Settings, fill, select. What is this? No, I wanna. Oh, maybe I can just cut all. I guess. Yeah, perfect. Okay. Right. So our scanner sits in here in the middle, and then it scans. Okay, maybe that was not very obvious here, but there's like this cube. Okay, I can. Okay, let's make a cube here. And here. Perfect. And then we have this here and here. So we have this cube, which is the area in which our scanner is listening for information. So how do I do the scanner? So the scanner sits in the middle here. I don't know if that's obvious. That's definitely not obvious. That's the middle. But the thing is, we have like things all around here, which are our beacons, and our scanner is sending out messages to or some sort of frequency out to figure them out. So let's see. So perfect. So here we have beacons that are 1,000 units away from the scanner have the precise position determined relative to the scanner. Okay. So basically, this distance here is at most 1,000. Can I just write 1,000 here of whatever this metric is? I guess it's 1,000 meters, maybe. Oh my god! Wow, that's horrible. But in every direction, this is 1,000. So, right. So, the scanner sits in the middle, and it listens to a cube around it that is 1,000 meters in every direction. That's all the area it can, the volume it listen to. So the submarine has automatically summarized the relative positions of the beacons detected by and each puzzle. Perfect. Okay. So our input, we can already open it. It's down here. Get a puzzle input just to see how it looks like. Okay, so we have a bunch of scanners, and they're the coordinates of things that they've scanned, and those are relative to the scanner. So these will never be more than 1,000. or less than minus 1,000, and this one here is going to like itself is set at like 0 in the center of the cube. So if that's the cube, then each scanner is always in the center of the cube, and it listens to a cubic area around it. So let's see. Yes. So for example, if a scanner sits at there, and there are beacons at blah blah blah, the scanner could report that the first beacon is at 1,000 relative to the scanner, but would not detect the second beacon at all, because it's even further out. Yeah. Okay. Okay. So that was just an example to clarify this. Unfortunately, while each scanner can report the positions of all detected beacons relative to itself, the scanners do not know their own position. Okay. So the scanner doesn't know where it is. It only knows where its neighborhood is. So you'll need to determine the positions of the beacons and scanners yourself. Okay. The scanners and beacons map a single continuous 3D region. This region can be reconstructed by finding pairs of scanners that have overlapping detection regions, such as that there are at least 12 beacons that both scanners detect within the overlap. 12 scanners. That's a very specific number. The scanners and beacons map a single condition. Okay. Okay, so we need to find scanners that have overlapping regions. So this is one scanner, and let's say, can I make a new layer? Oh, each. Okay. Each thing I draw is a complete new layer. That's a bit annoying. Okay, so then maybe we should use Photoshop. So far, I'm trying to. So we need. So by figuring out that 12 beacons have. Oh, it's opening the wrong page. Come over here. Anyway, so I'm not seeing how the stream is a bit delayed, but not too much maybe. Yeah, okay. Let's see. Perfect. Where's Photoshop? Come on, show yourself. Here it is. So let's make a new file. Let's whatever. Let's name this beacons, or like Advent of Code day 19, whatever. And that looks good. No, I don't. Ah, shit! I made it grayscale, but I can change it. Mode RBG color. Yes. So I want the background to actually be white. Why do they? I want this to come here. Perfect. So if we take a cube, let's say. Now I'm thinking if we had a 3D software, that would be even better. So let's do a cube here. I think the easiest way to do it is with this. So I'm gonna make a new layer. Oh, what is that? Is that a window down here? Okay, that's strange. So I'm gonna make this. Okay, I see one potential problem. Maybe I'm over-engineering this, but okay, let's do this like this. Whatever. No, so let's. We have our brush here, and we want it to be actually a pencil. Yeah, so let's do like maybe 4 pixels. And we want it to be 100% hard. Perfect. So if I go back to the pen, then I can do okay, can I draw let's see, stroke path with my pencil. We don't want to simulate any pressure, so then I can also can I move this? Yeah, okay, perfect. So okay, so I can that's funny. So I can move this here. All right. And then I can strike again. Stroke, yeah. Pencil, perfect. And then what we can do is remove. I don't want this shape anymore. Can I remove it? I can, perfect. And then I just want to do this stroke. Yes, with a pencil. And then this stroke with a pencil. No, I don't want to fill the path. I just want to stroke this, perfect. And then delete these again. This one here. Stroke again. Bam, bam. And then 1, 2. Stroke. Perfect. So now we have a cube. Wow, that took a while. And then we can have a new layer for our what's it called? Is there still a thing here? No, perfect. So we can have a shape. Can I create like a? I don't know. I'm just gonna paint this. And let's make this small and just make this a spaceship, or not spaceship. Sorry, a beacon. So our beacons are like this, and then this is a beacon. I can put it in the center, and then we have. Am I still over engineering this? I said I'm not going to spend too much time on doing things like that, and I think I am doing it. Now I realize my picture a little bit, maybe you can see the backdrop there. So, and then let's make this the beacons blue. So our beacons are blue. And then I wanted to have a bunch of beacons here. Right, so now we want to measure the distances from what kind of other shapes do we have? No, not really. No, I don't want to learn more. Go away. So we want to have this second stroke path. Let's change the stroke color to green, maybe. I don't know. Yeah, like this kind of green here. And then again, go back to, we don't want a brush, we want a pencil. And let's stroke this as, so this is the okay. Yeah, this would be like the distance from each of the yeah, so from our how's it called, from our scanner to the beacon, and the total area of this. So since our beacon is in the middle, then every at most, but this is not a cube then. Wait, if it's a cube, a 3D cube, let's say here, where is it? Yeah, the scanners and beacons map a single contiguous 3D region. Ah, all of them together. Okay, so each one of them should be only able to scan like a cylindrical area, actually. Detecting in a large cube centered on the scanner. Beacons that are at most 1,000 units away from the scanner have their precise position determined relative to. Scanners cannot detect other scanners. Okay, so they don't see each other. They only see the beacons. Yeah, obviously. But I think there's a mistake here. All beacons, each scanner is capable of detecting all beacons in a large cube centered on the scanner. But it's not a cube. If beacons can be at most 1,000 units away, then... Oh, okay, I'm thinking... okay, I see what's going on here. So this is not meters, this is our grid. So it always has to be a 1,000 pieces of the grid away at most. But still, won't this make like a sphere? Okay, anyway, let's take it at for what it is. They basically, we don't need to care about this because they will not give us an input that is over 1,000 or below -1,000. So that's all we need to care about now. So yes, so unfortunately, while each scanner can report the positions of all detected beacons relative to itself, the scanners do not know their own position. That was our problem. And we figure out a way to reconstruct this. So they're giving a two-dimensional example. So they say here that to figure out this. Oh wait, how many scanners do we have here? 27. We're given 27 scanners. Okay. The scanners beacons map a single condition with a 3D region, and this region can be reconstructed by finding pairs of scanners that have overlapping detection regions, such that there are at least 12 beacons that both scanners detect within the overlap. So each pair of beacons have to have 12 beacons scanners. So each pair of scanners has to have 12 beacons in common. That's quite a fair bit, which is probably good because then it means we are maybe with 12 beacons we are confident enough that we can tell where this scanner is. So they need to have 12 beacons in common at least. By establishing 12 common beacons, you can precisely determine, where the scanners are relative to each other, allowing you to reconstruct the beacon map for one scanner at a time. So they give a two-dimensional example here where they say this scanner sees these three beacons, and this scanner sees these three beacons. So if we would plot them out in this manner, they would. I'm starting to see a possible solution as well. So if we would plot them out this way, we would see that the scanner is here, and these beacons are so why is it at the bottom? Scanner 0 detects this, so it knows itself, and it sees that they are all away from it, like specific amounts, and the scanner 1 is sitting here and sees these like that. Ooh, I'm starting to see something. So let's see. Oh, the stream is quite behind actually. Why is that? What mode is the stream? Ultra low latency. So it shouldn't be too much time until now. I'm also looking at the live stream at the same time to make sure that you folks are having a good time. But I see that it is actually a few seconds behind. I guess it makes sense. Right. So anyway, sorry about that. Let's get back to it. So basically, what they're trying to do here is you can see that this scanner is itself placed in the distance between the other beacons, and this scanner is itself placed here. So we kind of like take a fingerprint of this, I guess, and if we try to match, like if you would put this on top of this, you would see that the beacons match, but the scanners do not. So basically, exactly that's what they do here. They overlap beacons and scanners, and they overlap these two grids, and this shows up. So how we would do this in this case would be that we would assume that so we know that every scanner can see 1,000 units away from itself. So we would always create 1,000, initialize a grid 1,000 by 1,000, where we place the scanner in the middle. And then how I would do it is I would just overlay. No, wait, that wouldn't work. Because if we overlay all the scanners on top of each other, um, would get a lot of noise. Okay, but let's think about this a bit later. So unfortunately, there's more problems. The scanners also don't know their rotation. Yeah, that's perfect. Yeah, because now we have 3 dimensions, so they can be facing in any direction. Um, so it's good that, yeah, okay. So each scanner is rated some integer number of 90 degree away. Oof. So 90 degrees away from yeah, so it could be rotated in all a lot of ways. So what I'm starting to see here is that we may have to like loop through different configurations for each scanner. um, I'm not really seeing a clear-cut solution yet to this problem. While other scanners might call that direction negative y or something. Okay, yeah, so the scanners are themselves out of alignment. But this would have been pretty easy to solve if people used like some sort of gravity based alignment system. So then that the floor is down and then you always know the alignment of the scanner. But well, the puzzle needs to be hard. So um, two scanners might agree. Okay, so two scanners might agree. Oh, welcome on the stream. That which direction is positive, but one scanner might be upside down from the perspective of the other scanner. In total, each scanner could be in any of 24 different orientations, facing positive or negative, okay, on considering any 4 directions up from that facing. Okay. For example, here's all right, yeah, so we have a few scanners here. I usually like to take the examples because, so let's start our notebook. Well, this is already feels like it's going to be, if the one yesterday that I had an idea on how to solve took really pretty much 3 hours, it took 3 hours to solve, then the 2 extra hours were just like having fun. But the problem I faced yesterday was that I was trying to prematurely optimize things. So let's make this basic this time. So hopefully this not gonna take too long. I'm going to set a deadline for myself because I want to go running. The weather is super nice outside. So let's say 11:30. Whatever we get until 11:30, and then maybe we'll see each other again during the day. Let's see. So day 19. This is our yeah. So this is a Jupyter notebook here. For you Python folks, you will definitely enjoy this. So let's see. We want this to be a code cell. So let's write some Python here. So let's take the example input. Set it like this. So let's parse the example input. So we want to so basically what I want to do here is for each line, for line in example input, if it contains three dashes, if in line, then right. So we also want to create. Yeah, I want to also. Okay, so there's a few things going on here. I want to make this into lists. I'm gonna also use our favorite NumPy library to make things Pythonically nice. But first, we're gonna initialize our scanners, and it's going to be a list. And let's see. So yeah, so and then so what I want to do is Oh, they're all called scanner 0? What, is that a mistake? For example, here's an arrangement of beacons as seen from a scanner in the same position but different orientation. Ah, sorry, no, that's I copied the wrong thing. By finding, okay, and by finding pairs of scanners that both see at least 12 of the same beacons, you can assemble the entire map. For example, consider the following report. We have these scanners. Okay, so that's the actual scanners I wanted to copy. So what I like to do in these puzzles is to first solve the example input and then exactly uh, and then try my own input. So we have a bunch of scanners. Because our coordinates are relative in this example, all absolute positions will be expressed relative to scanner 0, using the orientation of scanner 0 as if scanner 0 is at coordinates. Okay, so they are actually giving us a hint on how to go about solving this. So if we use any one scanner as ground 0, then we can try to see. Okay. So scanners. So if we just assume that scanner 0 is the center, scanner 0 and 1 have overlapping detection cubes. The 12 beacons they both detect relative to scanner 0 are the following coordinates. So how did they figure that one out? Let's see. 6, 18, 8, 24, and 6, 21. Is this easy to find? 6, 18. Scanner 0, scanner 1 does not have 618. So I think what they did here is, so these are the scanners. So these are the scanners. Yeah. So these are the scanners that in the other, these same 12 beacons in the same order, but from the perspective of scanner 1 are. Okay. So how did they find that this beacon is the same as this one? They look quite different. Because of this, scanner 1 must be at. Okay, so they figure out this position. Oh, but then I guess we don't get any hints on how to do that. Because then you can just figure out the distance of your common scanners. Scanner 4 overlaps with scanner 1. The 12 beacons they both detect relative to 0 are. Okay. So scanner 4 is okay. Following this process, scanner 2 must be at. Oh wow. Okay, that is getting a bit dense. Let's see. So what is the question here? Assemble a full map of beacons. How many beacons are there? Okay, that's a tricky one. So we only need to figure out. We only need to figure out how many unique beacons there are. So we could hack this a little bit. So what we could do. I think. I think maybe that's a hack, but I think what we could do is calculate the for each of these pairs, calculate their distance from each other. Yeah, because the distance from each other, it should be the same regardless of orientation. So if we actually take all these inputs and do a pairwise distance, three-dimensional distance. Let's see, can I do this with NumPy? A pairwise distance. Can I have what is this? Speed this in 3 dimensions. Array like. That's not very 3D. I think pairwise distances between observations in n-dimensional space. Perfect. Let's see. So it takes an array like an m by n array of m original observations in an n-dimensional space. Oh, I love this. So we can make a three-dimensional array and fill in. Okay. So I see. So there is one slight problem. Can I have a sparse and the array? So the no, but I want the documentation. I don't want this. CSR, no. Perfect. Let's search in here. Sparse. I see some sparse stuff here, but so sparse is because so basically what's going to happen is our array is going to have a lot of empty spots. How does the pairwise distance work? Maybe we don't need to construct a three-dimensional array. Maybe a 3 by whatever, like a two-dimensional array is good enough. Distance metric to use. The distance function will be all these. Oh wow. But we want Euclidean distance, which is the straight line distance. Yeah. So let's see. Do they have a nice example here of using it? We can just test it. Okay, so let's just do. So first we need to parse our input. So what I'm gonna do is I'm gonna parse all the inputs. Yeah. Okay. I'm just. Hey, welcome on the stream. So we're gonna parse all the inputs and make some nice arrays out of them. So let's do this first. So each scanner will have a name, basically. So if this or if it is a new line. So let's do this a little bit crude at first, or it's a or no, yeah, it was like empty maybe. Or line, or line is equal to empty. Then we want to continue. We don't want to keep it. Otherwise, for now, let's not care about the scanners. Let's just care about the beacons. Otherwise, so I'm gonna make this beacons instead. Beacons, regardless of scanner. Otherwise, just do append the line information in the beacons. So if I do this, and let's see what beacons contains now. Oh no, I messed it up. Oh yeah, it's of course it's a one entire string. So yeah, I need to split this by the delimiter, which is split none. The default value means split according to any white space. Now I want to split by new lines. So if we do this, perfect. Yeah, look at that. We get. So the problem now here is that, oh no, what is this? That's strange. It shouldn't look like this, right? Or maybe I didn't run it. Yeah, okay, now it looks correct. So what we want to do as well is we actually want to make this into a numpy array. So we're gonna be a little bit smart. We're gonna split this by comma. So the line here is going to be this, and each of those contains like this comma separator. So we can split by that comma, and I'm going to make this a little bit more hacky, and we're gonna do a list comprehension. So we're going for each of those splits. It's going to be 3 splits in each row. We are going to convert them into an integer. So I'm gonna say may integer coordinates for coordinate in the line split. So let's see. So if I run this and this, perfect. So now you see this is a two-dimensional array that contains three coordinates x, y, z, and a number of how they call it, the number of the coordinates. Yeah. So if we just make this NP array into an NP array, so that is nice. Maybe we don't even need to do that actually, but I'm gonna do that either ways. So let's do this a step earlier here. Let's replace beacons with itself as an NP array, numpy array. So now beacons is a nice array, which means that we can access it with in a lot of nice. But let's take the p distance. Okay, so that is that a beacons p dist? No. Okay, let's go back to documentation. Show me the documentation. So where is? Oh, it's SciPy. Oh, wow. I've been. SciPy is also pretty good actually, and maybe that's what we need to use it. Maybe NumPy doesn't have a pairwise distance calculation, but SciPy is also a pretty cool library that is good to get comfortable with. Welcome to the stream. SciPy, we want pairwise distance. So no, it does not have. Okay. How about pandas? Because I have, but I think I have scikit-learn as well. So maybe we don't need to go to pandas right away. Let's do pandas. Pandas pairwise distance. Let's see. Can we have? I always like to look at the documentation instead. So let's just do pandas docs. So let's take pairwise distance. No, Euclidean distance. Just distance. Essential basic functionality reindex. Okay, so this is not something that is available in Pandas. So let's we'll do scikit-learn. Sorry, not scikit-learn. SciPy. SciPy. I don't have it installed, so I have to fix that. Poetry, add SciPy, and I'm gonna be right back. I'm just gonna. No, it didn't work. Okay, what's that? Aha, okay. I see. That is a bit stupid. I've seen this issue before. That's a bit stupid. So basically, because the way I've set this one up, it thinks that we can take versions of Python that is up to 4. That's funny. But then we can say. Yeah, I can put it like this, maybe. Let's try again. Just to log, make sure that this. But that's a bit strange, though. Okay. Okay, they actually offer a solution. So maybe we can cancel this. Just paste this in. So basically the problem now is that my package manager tried to resolve the dependency requirements for scikit-learn, and I think because I allow up to up until version 4 of Python, they did not like that. So we need to limit it to at most 3.11. So let's try again. So now it should work. Yeah, perfect. See, SciPy has been added to my project definition file. So that should work. But let's write here. Can I? Oh, I can't. Yeah, I'll be right back. See you soon. Give me 10 minutes, 5 minutes, 5 minutes. I'm back. As promised, I'll be right back. Perfect. So, oh, my frappe is getting very flat now, but well, at least we have SciPy installed. So let's see. Let's check the chat. Hello, welcome. I hope you're enjoying your coffee. Let's see. Perfect. So now we have SciPy installed. So let's see. I also updated NumPy. So if we save this and restart so that we get access to everything, all the cool things we just installed, I can take this away. Import SciPy. No? What? That's strange. It should be here now. Import SciPy as SP. No module SciPy. Okay, where did I? It seems like it did install SciPy. Let's see. Which I'm using the correct shell. Okay. Oh. Oh no! It created a new. It It's called submarine. Okay. Submarine. Okay, I've been using the wrong one. So let's that should be, yeah. Okay, so I was using the wrong the wrong kernel. So now we should have yeah, exactly. So now SciPy should be installed. So what are we gonna try to do now is we have a beacon that has detected a bunch of a scanner that has detected a bunch of beacons, and we want to compute the distances among the beacons. So let's see here. So we have, these are the coordinates that we got from Advent of Code here. Let's see. These are the test ones. So my idea is just figure out how many distinct distances there are. So if I run this, beacons should be now perfect. So we have all the beacons here. So let's do this. Let's do SPP. Okay, I have to import the, yeah, I get what's happening here. I have to import the entire thing here. Spatial distance pdist. Okay, so spatial, no, okay, let's do it like this. Come here from SciPy import spatial dot distance. No, it doesn't work like this. Okay, spatial distance import pdist. Perfect. So we only want this one little function, and that's going to pdist. Let's see. It asks for an array-like thing. So these are our beacons, the ones that we've detected, and we want a metric. And I'm going to take, let's see. So this is an array. We put it in already. So let's hope it works like this. And I want to get the Euclidean distance. So the metric should be Euclidean. So let's see what this returns if I run. Okay. Let's see. What's the shape of this? 8,000. So what's the shape of our? Oh, what happened? So let's print a few things here. Let's print the shape of our beacon. So detected. Received beacons dot shape 0 beacon coordinates for beacons. So if we run this, we have 127. So that is 127 times itself. So like to the power 2. Is no, that's not nearly enough. Okay, yeah, because it does divide it. Yeah, so this, if we divide this by 2, and then okay, so then we have the diagonal, which we also don't need because minus let's see, no, but that goes too little. Minus 127, or maybe it should be done up here instead. So let's see here, minus 107. So yeah, that's correct. So basically what I calculated here is that so 127 to the power of 2 is the number of possible pairs of beacons, minus 127 because we do not care about the distance of the beacon to itself because it's always going to be 0. So we remove 127 pairwise distances, and then we also don't care about half of them because they are symmetrical. I don't care about the distance from me to the beacon, and I only care about the distance, one of the two actually, either from me to the beacon or from the beacon to me. It does not matter to take all of them. because they are also all positive distances. We're never going to have negative distances in this case. So let me just add this here. Print f. You should expect printf. You should expect a total of. Let's do this. So I'm just going to replace this here with this one. So in Python, to do a square, you have to do times like 2. You define it like this. So and I want it to be an integer as well. So it should always be an integer. A total of, so with in Python, if you do double star, it's to the power of a single star is just multiplication. So you should expect a total of pairwise distances. Yes, perfect. So let's get our beacon distances. Is that, and then just print out. Actually, what I'm gonna do is just to make sure. I mean, this always will work, so I don't think I need to do this right now. But beacon number of beacon distances should be this, and then just put it in here. And what I can do here is make sure that assert that the number of beacon distances is equal to beacon distances shape 0. And then I can print found calculated beacon distances shape 0 number calculated so I can distances. Let's see. Perfect. So now that we have these distances, beacon distances, let's see what I'm gonna attempt to do is just figure out how many of them are unique. So can I just do unique? No. Okay, can I do np unique? Yes. So can I do num unique? No. Okay, unique. So what does it do? Find the unique elements of an array. Returns the sorted unique elements of an array. That are three option. There are 3 optional outputs. Okay. So either so it either returns the indices of the input arrays that are unique. The indices of the unique array that are reconstruct the input. Wait, what? The indices of the input array that give the unique values. Okay, so this is just a pointer to where you'll find the unique values. This is the index of the unique array. The index of the unique array that reconstruct the input array. I'm not entirely sure what that does. The number of times each unique value comes up in the input array. So it will. Okay, so this is kind of like a count. So how is this set? So np unique, we give it our array, return index, if true, it returns. Okay, at this return index, return counts. Let's do the counts actually. That's so that will give us a little bit more information. So what we will return is how many times each of these distances has appeared. So let's see if my intuition was correct and that we can actually even do this to begin with. So let's take beacon distances and return counts is true. Yes. Okay. Wow. Okay. Maybe. Let's see. I can see some light in the. So what I'm gonna do first So because I see the number 4 here, which means that one distance appeared 4 times. So what I'm gonna do is I'm gonna import import matplotlib py plot as plot, so we also can plot something. So what I want to do here is np unique. It returns 2 things. So if I take the first one, it's the unique values. That's perfect. And the second one is the number of times they occurred. So so how many are there actually? So let's start with that. So can I do shape of this? No, okay, it's a tuple, sorry. So I can do shape of this maybe. 7,000, that is unlikely to be right. Shit, that's not good. No. Okay, I think what happened here is that out of pure chance, some oh no. So what did I get wrong here? So the distances to each other. Okay, so I know what's wrong here. Wait. So now we're counting all the possible combinations of distances, but the only ones we care about are the ones that happen at least more than once, right? Because, or will every beacon over... No. So why would... okay, what have I calculated here? So let's do some pen and paper exercise here. Hey, welcome on the stream. So if we take, we have all these here, and just let's just for the sake of this, let's make a copy of this one, and put it in a folder so we don't need to always do this. And this is another folder, and then we just move this out and rotate it somehow for no reason. Whatever. So what I want to figure out now is, so these, let's say these 2 scanners had a common, like overlapping area here. So these should have, yeah. So these should have common, like these beacons should be common, and then we have beacons that do not overlap. So if I make a few more copies of this, and let's yeah, maybe like this, and another one like this. So if I sorry, so I have a few copies of this problem now, right? Oh, they look, let's not make them look the same. That's going to be very confusing. So if I flip it a little bit more like this, maybe. So let's try to figure this out. So we have a bunch of scanners in the area that are rotated in different orientations, and what we want to find is how many beacons there are. The scanners do not, like, even if they were in their area of scan. So the cube is not really a cube, but yeah, I tried my best. Sorry for that. The cube is showing the area where the scanner can actually see. So when they overlap in these regions here, let's just assume that all of them are in the same alignment for now. So they do overlap. So these 2 beacons here, they should have the same distance among them, regardless of if it's this scanner that is seeing them or this scanner. So they should appear, the distance between those beacons should appear multiple times. So my assumption is that, okay, so these beacons here are not visible to anyone. Same with these ones here, but what is problematic here is that we have 127 coordinates for beacons. So we cannot have more than 127 beacons, because like these, some of them have to be common between them. So maybe, what if I try to only look at the ones that are, let's take this away. So this is the times each pairwise distance appears. So maybe we can try to take all the ones that appear at least more than once. So let's say more than one. And what I'm gonna do here just quickly is to just, can I just sum this down? Yes. No, that is still not correct. It's let's see here. What was it? So we took the example. Oh, I have too many. We took the example that was given in our input puzzle here. So that's this one. What's the result of this? They say you have to have, yeah. So the fullest of beacons relative to the scanner is this one, which is 79 beacons. Okay. Can we brute force this by doing that? So, no, that's definitely not right. So my issue here is that, okay, beacons that is, okay, yeah. My problem here is that there's a lot of beacons that should have the same distance. Because we counted, so what we've been counting is the distances among the beacons. Among all the known beacons. So this distance here should just appear twice. This distance here should appear once. But it could happen that this distance appears also somewhere else. Like these, actually this is a perfect example because I've made copies of these. So this distance is the same as this one. So it could be that even though they did not observe the same, it appears somewhere else. So maybe my way of solving this now is wrong. I tried to hack this now. So by looking at this, what else could we say? So from the problem, it says, if you find 12 beacons in common for a scanner, between two scanners, then you can be certain that you can figure out the alignment and everything of those scanners. Let's see. I see some familiar faces came and said hi in the in the chat. Perfect. Hi, hello everyone. Nice to see here. I don't know if LinkedIn is the right place to post this, but I feel like I don't know, YOLO, whatever. Right. So I promised that I'm gonna go running in half an hour. So because the weather is really beautiful outside, so let's see if we can get somewhere in half an hour. Right. So we have the beacons. So the pairwise distances did not help because the problem is they can appear in different locations, be the same. So I think, so when I take the unique pairwise distances here, we see the ones. Okay, yes, I know what's the issue. We don't care for distances between things that are more than 1,000 for now, let's say. I know that this is still not so we want it to be at most 1,000. Okay, we're getting somewhere. So because there is one constraint that we know, that we can't see further than 1,000 units. So two beacons can never be observed further apart than 1,000. Right. So then I think what the problem has become now is that, let's see, um, is that we are counting far too many distances, because we're gonna count distances outside of these as well. Okay, I see. So what I should do, yeah. So the limit I should actually enforce is we should only count pairwise distances per scanner. So implement that. Um, so we are, for now we're skipping the scanner input line here, but we're actually going to use this. So if so let's split this into separate things. So if line is equal to nothing. Oh yeah, okay, I already had this, but doesn't matter. Then continue. Otherwise, if the line it contains the triple dashes, then so we can take scanner name here as nothing, as a string, empty string, and then we can update the scanner name to be the content of the line, and we can actually replace we don't want the dashed lines. We can remove them, and we can strip white space as well, so we don't get white space. So what we want to do now is we have this coordinate here, and we want to extend this. Can I do this? I don't remember. Let's test this one out. Let's take a new. Let's say I have this array here, and I want to add. This is going to be a problem. We cannot mix strings and integers. So what I'm going to do then is I'm going to capture the digit of the. So we're going to import another library, the regex, our friend. Import so we can let's do this. So when we are in here, instead the only thing we need to take is the find all, and it's only going to be one. We know that, and the pattern is going to be any number of digits. So if you're not familiar with regex, is it plus or star? I don't know. It's regex is a pattern matching language. So what it says here is match any digit from 0 to 9, and this means how many times no, that's sorry. This is how many times it occurs. Yes, because the star is a wild card. So, and then we want to line, and we know it's going to be one match. So I'm going to keep the first match because this will return all the matches. And what I'm going to do is I'm going to append this as a fourth coordinate. So let's see if I do this 123. It works, okay. But actually, yeah, okay. So what I'm let's think. Beacons, scanner name, and scanners. I'm gonna make another array that contains scanners. So it's scanners. Append scanner name. So this way we know it maps one-to-one. Every row in beacons maps to a scanner, and the reason for that is because we want to be able to to only look at each scanner separately. I'm thinking now maybe there is merit into actually adding this as a fourth dimension in here instead of another array, because of an implementation thing we can do nice later. Welcome on the stream. Let's see. So let's try this one out. mm, so if I just run this now, I should get. Oh no. Oh yeah, this returns everything. No wait, what? What's the scanner name here in this case? No, it's 0. Ah, okay. So one issue is that I want this to be an integer, so I can cast that immediately. Another issue is. Okay, let's try this again. No, but it's complaining about something else. Coordinate line. Yeah, yes, okay, because it's not continuing here. Yeah, it's trying to. Yeah, we can skip the line because now we know it, right? This should work. It's a little bit. Yeah, this should. So the scanner name can be 0 here for now. So this should work. Yeah, it did work. Okay. Scanner name 4, and then I can do scanners. And then we have an index. Yes. So this maps 1-to-1 to our beacons array. So, hey, welcome on the stream. And then we can, since it maps like this, basically what we can do is say that we want for each where, yeah, so np where, oh yeah, this is still, or can I do it without scanners is equal to 0? Does it work? Okay, it doesn't work because this is, scanners also needs to be an numpy array. So let's fix that. Scanners is equal to np array scanners. Perfect. Awesome. So then this should work now. Yes, perfect. So we get the indices for which the scanner is equal to 0. So what I'm gonna do is I want to loop through all the unique scanners. So for scanner in let's see, let's make this here scanners unique. No, we could do this np unique. Perfect. So we can do this. So for scanner in scanner unique scanner, so this will go through all the unique scanner IDs we have, and I want the scanner to. I want to find all the indices where my scanner exists, and then calculate the Euclidean distance of those. So let's make this happen. So we want to create so save them also somewhere. So beacon distances. Let's see. So we get the indices. So how can I use this as a scanners like this? Can I do that? Fine. That's fine. I can put it to 0. Yeah. Okay, that works. Okay, perfect. So I get all the. Yeah, that's correct. So this shows me all. So this returns all the indices where the scanner is 0, and the scanners is where we have all the names of the scanners per row for the example that we have above. So let's do this. Thank you, Andreas. Andreas is an awesome friend from work, insane streamer. Big high five. Thank you. Good luck, have fun, enjoy your Sunday. He's the pro streamer, so I'm learning from the best here. So yes, so let's take this. Let's go. Let's see. I'm thinking out loud here now. Yeah. So mm, we want to look at the pairwise distances for each beacon in each scanner. So we're taking each scanner here, so we know from our index we know where that scanner is, and we actually only want to return the distances in the beacons. So okay, not even return them. We wanna measure their pairwise distances. So if I do this, yeah. So we want to create an array here. Append all this thing. It looks super ugly, so you know we have 20 minutes left until I have to go running. So let's see how far we get. Beacon distances is an array, and let's make this happen. Let's see. Let's roll. Okay, we got something. Beacon distances. So we get an array of distances. How is that possible? Something strange is going on here. Let's see. How is it possible that two beacons are further apart than 2000? It should not. That is a bit interesting. So, should I wait? Actually, I'm using the wrong distance metric as well. Do we have city block? I think that I wanted like this. Actually, yeah, I think Manhattan distance between the points. So I think we actually want this one and not we want a distance that is not actually floating point distance, because maybe that is introducing some errors here. Manhattan distance. So Manhattan distance takes its name from Manhattan itself, and and it's basically measuring the distance in a grid. So that's very short. It's a Wiktionary explanation. Okay. Is there others on Wikipedia? Perfect. So taxi cab geometry. So I want to see. So what is the Euclidean distance in taxi cab geometry? Red, yellow, and blue paths all have the same shortest path of 12. In Euclidean geometry, the green line is this one. Yeah. So which one is the Manhattan distance? I think it's the blue one. Let's see. City block. But I've never seen it written out like this. City block. Compute a city block or Manhattan distance between the points. Yeah, because we don't want to. So what's the Hamming distance? Yeah, we don't want to have floating point distances here. So let's try city block. Yeah, perfect. So everything is yeah, it looks great actually. How does it calculate it in 3 dimensions? I'm not entirely sure. So maybe that's why these. Okay, so maybe something is off with the way I calculate things. So let's see. Square form. No, we don't want square form. Pairwise distance in between some observations in dimensional space. They don't have a good example here of how to use this. Yeah. Distance. We have different pairwise distances between observations. Vector form distance, square form distance matrix, and vice versa. What is this type of distance? What distance between each pair of the two collections? No. City block. Yeah, we saw that. Maybe it's interesting. Maybe they have a little bit more information in it. Is there Euclidean here as well? No. There was. So I saw it. Yeah, there it is. Dice Hamming distance between two. The Hamming distance is how many if I remember correctly, is like how many changes you need to make to arrive from a input array to an output array. So it's like they usually use it in text. So you would say the Hamming distance between words is how many edits you have to perform in the initial word to arrive to the destination word. It's not interesting right now, but let's see. No, okay. No, I think I'm confusing it with another. Yeah, doesn't matter. Okay, I'm not gonna dive into it. We only have 15 minutes left. City block. Compute the city block Manhattan distance. Right. So this one here takes two. So how does it compute? Okay. That looks pretty reasonable. So it takes. Right, so the distance. So I think that should be fine, actually. So if we use, so this will treat everything as a one-dimensional array. So it basically compares these two and measures the city block distance between them, and that is fine because that's how we define this as well. So it's this kind of. Alrighty. Let's see. What's going on LinkedIn here? Just do a quick distraction. Oh, that's pretty fun. Some people, very familiar faces, passed by. That's really nice. So let's see. So what I want to do now is that now that we have all the distances per inside each beacon, so the only tricky thing here is that these distances are not very meaningful anymore since they are these kind of city block distances. So they are supposed to be longer than we would like them to be. So but they should always now hopefully be the same regardless of where you're looking at them from. Does that make sense? Let's find out. So for each, so we have all these distances here. Beacon oh wow, I'm adding a lot of things. Beacon distances. So we want to merge them into one. So can I just how do I do this? Or I can just make this one like an all beacon distances and just expand it with for dist in beacon distances, all beacon distances extend with dist. So let's see how this will look. Perfect. And now that we have this, we need to calculate the unique distances, and And let's take the shape of that. That is far too many. Okay, my perception of 3D geometry is off. So, well, there was an attempt. I don't see how I'm going to... I think this approach was wrong overall so far. I was too hopeful. So my initial thought was I could just calculate pairwise distances of all the beacons inside the visible space. And these distances should always be possible, like, yeah, there should be a lot of duplicates if we like identify the same thing multiple times. I'm thinking at the same time now and talking, so that's a bit even more confusing. So actually one last thing, return counts true. Actually I want to try this one first before quitting. Let's do unique distances here. Let's save this and come down here and do this unique distances. Let's run this. And what I want to do is I want to take... This is not a fair observation to make though, but I'm gonna say for now that, okay, let's say that the times that let me think a little bit. Yeah, so in the so the second array that this returned is the times that these observations appeared. So if I do this is greater than 1, so I only want to count the ones that so you can sum booleans because they are pretty much 0 for false and 1 for true. So what I want to do here is oh, welcome to the stream. Nice. So what I'm gonna do here is I'm gonna count how many pairwise distances appear more than once, and that's still far too many. Damn it. So that's probably just random luck, I guess, at this point. Let's revert back to Euclidean for now, and try this again. Maybe this extra granularity gives us some insight. Yeah, it is okay. It does give us some clarity, but still, that cannot be so high. I think it's just because we have 127 beacons. We cannot be observing 219 unique distances. Overlapping distances. It's probably just that yeah, that's a bad way to try to solve this problem, I think. So I'm gonna close this stream earlier unsuccessfully, but well, there was an attempt. So word of caution, I'm gonna think of it while running. So if trying to solve this problem with counting the unique pairwise distances is not a good way to go about it. I'm gonna try to think of a better way maybe while I'm running, and if I feel like it, maybe I'll pop up in the stream again afterwards. Oh, Matthias, wow. That's a long time no see. I hope you'll make some really nice brew. I'm gonna go for a run and maybe come back in the stream later. But I do hope you enjoy your coffee, and thank you everyone for tuning in. That was a fun. I hope you had a good Sunday morning so far, and I hope to catch up with you around the internet. This is going to be something very irregular, so I don't have a plan on how often I'm gonna be popping up in and out of mm, a stream on YouTube. But maybe I see that at least like yesterday I did the same, but I did not post it on anywhere. I just did like a ghost stream. Just pop in and see if YouTube will invite anyone to my stream. And some people did pop up, so that was pretty cool. So yeah, have a good day, everyone, and we'll see each other at some stream at some point in the future. Have a good one.